we are going to consider unit vector in 2D. 2D as the x-axis and the y-axis. Along the x-axis, we represent the unit vector by letter I, and the position coordinate of the unit vector along the x-axis is represented by 1, 0. This is the coordinate of the unit vector along the x-axis. Unit vector means it is a vector whose length is equal to 1. Along the y-axis, the unit vector is represented by letter J, and the position of unit vector is represented by 0, 1. This means that along the x-axis, you move 0 step, and along the y-axis, you move 1 step. So in terms of the vector themselves, the column vector for I is 1, 0, and the column vector for J is 0, 1. Again, this implies that you move 1 step along the x-axis and 0 step along the y-axis, and along the j-axis is 0, 1, which means that along the x-axis you move 0 step, and along the y-axis you move 1 step. So on a Cartesian plane, the unit vector are represented as shown below. So on a Cartesian plane has the x-axis and the y-axis. We represent the unit vector as I, whereby the component is 1 step from the origin. Along the y-axis for the unit vector I is 0, and for unit vector J, it means we move 1 step along the y-axis and 0 step along the x-axis. So this is how we represent the unit vector on Cartesian plane when we are considering 2 dimension. Given any point like point 2, 3, we can express this in terms of unit vector, whereby we write it as 2, 3, and we separate it and write it as 2, 0, plus 0, 3. So that is not different when you have this column vector 2, 3. It can be written as 2, 0, plus 0, 3. When you want the x component together and the y component together. So it is 2 plus 0, which is 2, and 0 plus 3, which is 3. Then from here, we can, in the first case, we can factorize 2 out, and we'll be left with 1, 0, then plus. In the second, we factorize 3, bracket 0. Here, because 3 is outside, we shall be left with 1. And we note that up here, we have said that 1, 0, 1, 0, in this case here, 1, 0 represent vector I, and 0, 1 represent vector J. So this implies that this vector 2, 3 can be expressed in terms of unit vector I and J as 2I, vector I, plus 3, vector J. So in general, when you are given a column vector xy in 2 dimensions, it can be expressed in terms of unit vector as xi plus y vector J. So any point xy can be expressed in terms of unit vector as xi plus yj. So in this video, we have briefly looked at the unit vector in 2 dimensions, and we have seen that the unit vector is a vector whose length is equal to 1. So the size of our unit vector is equivalent to 1, and you can call it size, magnitude, or modulus. It means the same thing. Now, the unit vector in 2D in Cartesian plane, we have unit vector I, which is represented by its component is 1, 0, and vector j, whose component is 0, 1. In terms of column vector, unit vector I, it will be represented by 1, 0, and the unit vector j will be represented by 0, 1. This means that you move for unit vector I, it means you move 1 step along the x-axis and 0 step along the y-axis. That is unit vector I. For unit vector j, it means you move 1 step along y-axis and 0 step along the x-axis. And any vector, any column vector in 2 dimensions, 2, 3, whereby 2 means you move 3 steps along the x-axis, you move 2 steps along the x-axis and 3 steps along the y-axis, can be rewritten as 2 plus 2, 0 plus 0, 3, whereby we can factorize 2 in the first column vector and 3 in the second column vector to be left inside the bracket with the 1, 0 and 0, 1, whereby 1, 0 is equivalent to unit vector I and 0, 1 is equivalent to unit vector j. So in general, when you have a column vector xy, whereby x represents the movement or the displacement along the x-axis, and y represents the displacement along the y-axis, can be expressed in terms of unit vector I and unit vector j as shown here, where x is the component along the x-axis and y is the component along the y-axis. So thanks so much for taking your time to learn with me on unit vector in Cartesian plane, whereby we have briefly considered the unit vector in 2 dimensions. For those who are new, consider subscribing to this video so that you will be notified whenever there is a new release. You can also share, comment, and subscribe to this video so that we may learn together. Thanks so much for watching. See you in the next video. Bye bye.